Dealing with quadratic equations, right? Up till now in the class, the first half of class, I've taught you 4 ways to solve quadratic equations. We solve quadratic equations by the quadratic formula. We solve them by completing the square. We solve them by factoring. We've been just swimming in a sea of quadratic equations. Some of you are drowning. Some of you are staying afloat, barely breathing. But we're just swimming in quadratic equations. The second half of class now, we're going to be graphing these puppies. We're going to graph quadratic equations. That's where we're headed now, towards the end. The light at the end of the tunnel. Okay? Now, this title, vertex form of a parabola. On this title, I'm going to put 2 arrows where you see parabola. Let's draw 2 arrows from the word parabola. Here and here. Do this on your notes. A parabola is just a word for the way a graph looks if we graph a quadratic. If we graph a quadratic equation, it's going to look like a parabola, which is like this, like a U, and it goes on forever. That's if it opens down, but a parabola can also open up. And some of you have taken Math 2 with me before, you guys will recognize that. So when we graph quadratic equations, they look like parabolas, like this. When you guys were in Math 1, you guys graph linear equations that look like lines. There's a bunch of lines, linear. But now we're dealing with quadratics. Now, the graph can open down like this, or the graph can open up. But either way, there's always a highest point or lowest point. That highest point and lowest point is called a vertex. Go ahead and put an arrow from the word vertex and point at the vertex of either parabola here. I drew 2 parabolas, and so are you. Go ahead and do that. Now, what do I mean by vertex form? Well, here's what I mean. Look at this quadratic equation that I'm going to show you here. You're going to write down. I'm going to write this equation down. Y is equal to A. You guys recognize A. Remember ax squared plus bx? We have a quadratic equation now in a different form. Go ahead and copy this down and go and write these arrows, vertex h, comma, k. And I'll explain right now. So I'll give you about a minute to copy that down nice and neatly, nice and big too. You're going to see this a lot in the next few weeks. Okay, so what do I mean by this vertex hk? Notice how up here, when I had you put an arrow at these 2 points of vertex, when we graph, those points on our graph, our coordinate plane, are going to be an x coordinate and a y coordinate, and that's what this hk means. This will be your x coordinate of your vertex. This will be your y coordinate of the vertex. If you're able to get the equation to look like this, you would be able to see your vertex right here, your h and your k. But since we haven't been graphing, let me just remind you what I mean by a vertex being an x and y coordinate. Let me go to my graphing calculator online, which you guys will use today. This graphing calculator is called desmos.com. Some of you recognize this from the class previously, if you had me before. So desmos.com on your laptops, you'll type it in this internet address, and you have this graphing calculator program going on. What I'm going to do is I'm going to type in the quadratic formula or the quadratic equation we use for warm-up. The one from warm-up, let me go ahead and type it in. But now I'm going to, instead of writing 0 is equal to something, for instance, on warm-up we had, here's our equation for warm-up. But instead of writing it this way with a 0, instead of 0, I'm going to write y equals, because we're going to graph it now. Look at it. I'm going to write this equation. Okay, we have x, and now we have y. Instead of 0, I'm replacing it with y. And let's see how this graph, what this graph looks like. This is the one from warm-up, x squared plus 12x plus 3. Watch. Let me go to desmos.com and watch how it behaves. Let me come up here on the upper left and type in y equals x squared plus 12x. Was it plus 3? What was the last? What was the c value? Plus 3. All right. Look at the graph that came up. See that red graph. If I place my finger over the graph, watch this. Look at all these coordinates on the graph, the x and y coordinates. Come down and it starts coming back up. All these coordinates are actually solutions to this equation. Remember the word solution? They're order pairs that satisfy. In other words, any point I pick on the graph, like that one there, negative 9.42 and then negative 21.304. If I were to substitute this for x and that for y in here, it would result in a true statement. It would satisfy. And that goes for any point. Okay, any point on this parabola. Now, what would be the vertex of this parabola? Well, look at the bottommost point right there. There's your vertex. The x coordinate is negative 6. The y coordinate is negative 33. So going back to our notes here, when I talk about HK, when I talk about a vertex here that you just wrote down, I'm talking about your x coordinate and your y coordinate. But just for the formula, for the structure, we just call it HK. But that's all I'm talking about with your x and y coordinate of the vertex. Now, next slide, we're almost done. Go ahead and copy this down here. I'm going to write standard form, and put a squiggly, and then put vertex form on the right. I'll give you about a minute to copy that down. Standard form versus vertex form. Copy that down. So looking at standard form on the left, up till now in this class, you guys are already used to standard form. You guys are no strangers to this structure, ax squared plus bx plus c. You already know that. Up to now, though, however, everything we've been doing, your equations that I've been throwing at you, instead of you seeing a y, what would you always see here instead of a y? Well, we'd see the x over here. We'd see something over here, something different. Think of warm-up once. Let me go back to warm-up. What would you see? Right, we'd always see a 0, because all we were doing up till now is actually solving for them. But now, since we're going to be graphing, we see a y now. We're going to be graphing these parabolas. And remember, every point on a parabola, or on any graph for that matter, every point has an x value and a y value. They're called coordinates. That's from Math 1. You should know that by now, how to graph basic points on a coordinate plane. That's why you see a y now. Okay, now, so you guys are no strangers to this. What I'm trying to teach you today, just the beginning, we're going to continue tomorrow. Obviously, I don't want to throw it all in one shot. I'm going to kill you and give you nightmares. But what I'm going to do right now is I'm going to use the equation from warm-up. And I'm going to use the equation from warm-up, and I'm going to transform this equation that's in standard form. I'm going to metamorphosize it, tweak it, adjust it, do some finagling to the left and right side to make it look like this, which is the vertex form. Because the beauty of this is if you have an equation in standard form and you're able to change it to vertex form, you can actually see the vertex. It actually ends up being that number and this number. You can actually see it. And we can do some adjusting, finagling on the left, do some tweaking and stuff, and turn into this. You can see the vertex, it becomes HK. Look at the bottom point. Or if it's opening down, it would be the top point. But for this example, it's just the bottommost point. And notice H is this number, K is that number. Okay, that's the goal right now. I'm going to throw one example at you right now, the one from warm-up, which we already solved. Remember, we solved it by completing the square. We're going to use a warm-up example, and I'm going to show you how to go from here, standard form, to vertex form. Just one example. Stay with me. Here we go. Here's example 1. Here we go. Now, we already graphed it, huh? Because right here on decimals, we already know the vertex, right? It's right there. -6, -33. Well, what I want to do is answer the phone. That's what I want to do first. Hold on. Just one example. One from warm-up. Looking at this example, this equation is in standard form. You can see your A value, you can see your B value, you can see your C value. You can do that in your sleep by now with everything I've trained you. What is my A value here? Anybody? 1, huh? Whatever's in front of x squared, so it's A is 1 in this case. B is 12 and C is, cool. So we have an equation in standard form. That's what we've been used to. We're now going to mutate this equation to look like vertex form. That's the mission right now. I'm only going to do one very slowly, and then tomorrow we'll do some more examples. That's where we're headed. Watch, here we go. The cool thing about mutating this is you already know how to do it, you're not aware of it. It's like what we did a few weeks ago on factoring. You actually know how to do it. Let me show you know how to do it. Watch. Now, using logic, strict logic, an equation is like a balance. Whatever you do to one side, you have to do the other because they're equal. It's a very powerful symbol. So what we're going to do right now is we're going to add, so this first step, we're going to add b over 2 squared to both sides. You guys are no stranger to that. Remember, that's the step of completing the square. Let's do that to both sides. And you're going to see what happens, right, Acevedo? Stay with me. So if I add b over 2 squared, let me do the b over 2 right now. Off here on the side in red. What's our b value again? 12. So watch this. So that'll be 12 over 2 squared. And that becomes 6 squared, right? That becomes 36. And that's when we know this from warm-up. Remember, we solved it by completing the square. So let's do that. Let's add 36 to the right and add 36 to the left. There we go. Stay with me. Okay. Now here's something a little bit different now. Look at this move, this logical move I'm going to employ. I want you to witness. See, mathematics is nothing but logic. Logic are the rules of thinking, correct thinking. It's all that math is in the final analysis. Watch this logic. That's why you do math. It trains your mind gets stronger in logical thinking. Watch. On the left side, I added, look at it's a balance. I added 36 to the left, 36 to the right. On the left side, what would I have logically? What's y plus 36? One more time. 36y. I have a y, and I'm adding 36 to it. I'm sorry. Okay, let's go. Miss Rojas and Minister. Go ahead, Miss Rojas. I have y, and I'm adding 36 to the y. What do I get? Okay, so one more time then. Y plus 36 is what? 1 plus 36 is 37. What happened? Y plus 36. It'd be y plus 36, huh? Yeah. Y plus 36. 36y would be 36 times y. But I got a y adding a 36. This is y plus 36. A 1 from the y. What you mean is there a 1 coefficient? Yeah, there's always a 1 coefficient. But these are not like terms, huh? leave it that way. Cool. Now look at the right side now. Look at the logic again. Logic. We could, if we wanted to, add these two numbers. Look, because there's just numbers and numbers. 36 plus 3 would be 39, I think. But we're not going to do that. Look what we're going to do. Here's a little movida maneuver. That's going to allow us to get this equation into, remember our goal is to get it looking like this, the vertex form. Look what we're going to do. Look at the logic here. Let me rewrite this polynomial on the right. X squared plus 12x. I'm going to put the 36 next to the 12x, and I'll put the 3 next to 36. So we have a 4-term polynomial. We have some like terms here, right? But we're going to resist the temptation of just getting them together for now, and you'll see why. We'll just leave it like that for now. Okay, here's what we're going to do now. Look at vertex form, how you have this binomial squared. Do you guys see that? A binomial x minus h squared. Well, it just so happens that this trinomial right here is going to be, this, look at this trinomial right here. This trinomial is actually factorable. Because remember, we added the b over 2 squared. Remember completing the square? So look at what ends up happening. Watch this. Look at the next step. Y plus 36 is equal to, let me factor this trinomial without the 3. I'll leave the 3 to the side. If I factor this trinomial, what two numbers added to be 12 but multiplied to be 36? 6 and 6. Now, watch this. X plus 6, X plus 6. Don't forget the 3. 3 doesn't just disappear. Logic. We're just using logic here. So all we've done is rewrote the trinomial into two binomial factors that are the same. Let's keep going. How can I rewrite these two binomials? Right. It's this x plus 6, the second power, because x plus 6 times x plus 6 means that, plus 3. It's starting more and more to look like this. Look at it. It's starting to look like this now. You guys with me? But looking at this, well, let's see, right now the A, what would be the A? What's in front of this parenthesis? 1, huh? So A would be 1 so far. Even though we don't see it, there's a 1 there. But now looking at the vertex formula, Y alone. Very nice, Ms. Rojas. Y is by itself over here. Y is not by itself. What would we do? Logically. Subtract 36 from both sides. Logic. Let's subtract 36 from the left and from the right. We are almost done. You guys are doing good. Watch what happens. Logic now. If I subtract 36 from the left, 36 from the right, look what we have. What is 3 minus 36? Close. Negative 33, right? So far, so good? Okay. Now, this is looking now like vertex form. Now, vertex form says, let me get this down over here. Stay with me here. Move this over here. Let me compare this to vertex form now. Watch. Okay. So the A value right here is going to be 1. Here's your X, right? Now, the form says to make sure this is a minus. Okay, but we have a plus here. So what can we do to this expression to make a minus here, but make it the same expression? Instead of a plus, we're making a minus. What can we do to this binomial and make it a minus here instead of a plus? Please say, go ahead, Mr. Lester. I can hear you. No, document it. I think you had your arms done. Thanks, Rojas. Well, let's do it here. Watch. Is not, watch this, is not x plus 6, couldn't I write x plus 6 like this? X minus a negative 6? Isn't x minus a negative 6 the same as x plus 6? Right, which is that. That's what it is, right? This becomes that, huh? So again, strict logic. X plus 6 is really the same as x minus a negative 6. But why do I want to make it x minus negative 6? Well, because I want to get it to look like this. X minus, to get x minus. H then is negative 6 now, huh? Squared plus negative 33. Okay, there's your k. And remember, your HK is your vertex. And remember, I graphed it a little while ago on our graphing calculator, and you saw with your own eyeballs that the vertex was indeed negative 6, negative 33. That was the vertex, remember, on a graphing calculator? So our final, so we're virtually done right here. This is vertex form. Right, without the minus, huh? But just know that if it's a plus something, then you already know to rewrite it as minus negative 6. Right? That's the only thing you got to remember. And then this will be a plus out here. A plus. No. What you mean by that is that you always have a subtraction here? Yes. Yes. In that case, yeah. The square is just right there. Done. Right. Because remember, x plus 6 squared really means x plus 6 times x plus 6. And we're dealing with a quadratic equation. It really means this, huh? See, this means this. Okay? Okay, I'm going to go over more examples tomorrow. Just a minute. Hold up. All right. Now, with a partner,